This is section 5.6, and we're going to do problem 3 here. But before we start problem 3, let's look at the population growth. This says population growth, but this could also be for bacterial growth. This is our exponential growth pattern, which again, that coronavirus is showing exponential growth. So this is one of the formulas that they're using to come up with that modeling where they're projecting 100 to 240,000 deaths in the United States. So let's see what all these letters stand for. So P sub t, that's the function. P sub 0, that's called the initial population at time 0. So that's whatever the population started out with. And then P of t is the population after time t. T is the amount of time. K is the exponential growth rate. The growth rate and the amount of time must be the same unit. Like if one of them is in years, and the other one must be in years, and so on. So let's go to the next page, and here's the exponential growth pattern. And of course, this one is a pretty smooth pattern. If you had looked at the exponential growth charts that they're using on the TV and all the news channels right now, you'll see that it looked more like this. It started out really flat, and then it started going up very quickly and very straight. So that's exponential growth is what that virus is doing right now. All right, so let's go use that formula to come up with a problem. So in 2009, the population of Mexico was about 111.2 million, and the exponential growth rate was about 1.13% per year. Find the exponential growth function. So we're going to start with that formula that they gave us on the first page, and that formula is P of t equals P of P of 0, the initial population, times e to the kt power. Now we're going to start plugging in the numbers. So we don't know the final population, but we know the initial population was 111.2. We're not going to put the million in. Then e stays e. And then our growth rate, is that 1.13%. But remember, when we're doing calculations, we can't have a percent, so we're going to move that decimal back 2 places and get 0.0113. So this is going to be e to the 0.0113 t power, and there's the answer for A. That's the actual growth function. Now it wants us to estimate what was New Mexico's population in 2014. Well, the initial year was 2009, and the present year is 2014, so you subtract those, and 5 years have passed. So that's our t now. So we're going to go into this formula, the population formula, P sub t, but now we're finding P sub 5. We want to know what the population is in 5 years. So we get 111.2 e to the 0.0113 times 5 power. Now you just pick up a calculator and plug that in, and you get the population after 5 years is 117.7, and don't forget the word million people. So there's the population after 5 years. All right, now the next one wants to know, how long will it take for the population to double? All right, so this time we want the population to double. Well, we know in 2009 the population was 111.2, and we want it to double. That means we want to multiply that by 2, and we get 222.4. Now that's the population we want to get to, so we're going to take our equation, P of t equals P of 0, which is 111.2 e to the 0.0113 t power. But now what we know, what this 22.4 is, that's our population that we want to get to. So we're going to take the P of t out, and we're going to put in its place 222.4 equals 111.2 to the e to the 0.0113 t power. Now we're going to divide both sides by 11.2, and notice on the left we get 2. So if we want the population to double, we just get a 2 there, and we're left with e to the 0.0113 t power. Now we're trying to solve for t, so we're going to ln both sides. On the left side, we have ln of 2, but on the right side, look what happens. ln of e, remember, that's a base e of e, which is just 1, so we actually have equals 0.0113t. Now we're going to divide both sides by 0.0113, so we get ln of 2 divided by 0.0113, and that equals t, and that's the answer. Of course, you would put that into a calculator.